Okay, so here is a video of the aluminum and hydrochloric acid experiment. And you can see I have in my flask here about 1 gram of aluminum. I measured those out on the balance. And then I have here some 3 molar hydrochloric acid. It's in a, looks like a mouthwash dispenser. And I'm going to put 50 milliliters of hydrochloric acid in that aluminum by squeezing the bottle and getting it up there. I don't think you can see the top, but I'll just do it right here, okay? Got my safety glasses on. I'm not going to spill anything, so I don't need my gloves. I'm going to put 50 in there just like that. Now, you may not see this, but I'm going to pull it over to the edge where I can pour that 50 milliliters into the flask with the hydrochloric acid. Okay. And I'll move it back over here, and now we're going to have to wait a few minutes to see what happens here. So the aluminum starts reacting, okay? So what kind of reaction is this where I take a single metal and I put it into an aqueous solution of a metal with a non-metal? So I have aluminum metal and I put it into the solution of hydrochloric acid, which is HCl. And the H acts like a metal and the Cl is the non-metal, the chlorine right there. And as you can see, it's starting to react there, all right? Starting to bubble and get some fizzies in there. I think maybe I'll turn the lights off too. We can see what's going on a little bit better. Don't do this in class that much, but this might add to it a little, okay? So I'm gonna move this around here. Maybe we can get a little bit better view of it out this way. I don't know, let's see. Now, so you can see that I'm getting some bubbling, some fizzing, okay? It's turning color right there, all right? And you can start to see some vapor coming up right there, okay? It looks like smoke. So you'd be writing down some observations. What do you see? Is it getting hot? Is it changing color? What's the aluminum doing? Okay, is the aluminum still in there, or is it dissolving? What's going on? Let's put a match to it and see what happens, okay? If I can, right here. See if anything happens. Oh, look at that. Got a little bit of an explosion right there. I think maybe something's coming out of there. So we got some bubbling. It looks like smoke right there. I'll tell you what, this down here at the bottom is getting warm. Okay, it's not that hot yet, but let's see what else we can do with this, okay? So these matches are a little bit worn out. Looks like they got a little bit damp. There we go. I'll tell you, do that in slow-mo. I bet you can really see that flame going down and coming back up again. So something's coming out of there. And I'd say that it has a chemical property of burning, right? Let's look at it again. Ooh, yeah, we're getting some stuff there. Looks like a gas, huh? Got some kind of a gas coming out of there that we can burn. That is. Do it again here. I don't know if you noticed, but every time I do it, it starts going a little bit faster for just a second right there. See those bubbles pick up? And that's because I'm giving it a little heat, and heat tends to make chemical reactions go more quickly. Now that's probably getting nice and hot down in there. Hey, if you're in class, you could have been doing this too. But next year we'll hopefully be back to normal. Still going. Running out though, running out, okay? It's running out of whatever it's making. Oh, that's getting too hot to pick up right there. We can spin it around a little bit here, see if we see any aluminum in there now. I wouldn't say we really see any in there. It looks to be pretty gone. That's kind of burning my hands right there. That's not really smoke. It's more like a vapor. It's got a little bit of color to it, but it's more kind of like a steam. Oh, that was cute. That would be okay. That wouldn't scare your little puppy or something. You would probably think that was cute. I think that's about it. Whew. So now whatever it is we made is gone, all right? And that leads you into the question. So in the lab, there we go. You made some observations, hopefully, right? So pick a few of those that might give you, let you know that you had a chemical reaction. What happened to the aluminum? Did it disappear? I don't expect you to know exactly what it did, but is it still in there or is it gone? Okay. What's coming out of there? I don't expect you to know exactly what it is, but does it seem like a gas that is flammable that we can light? It doesn't seem like it's a solid or a liquid. So I'm just going through the conclusion questions right here just a little bit. All right. So you've got a bunch of observations and pick a few of those to show you had a chemical reaction. What makes me think this might be a single replacement reaction? Well, when you have a single replacement reaction, you take a single metal, such as aluminum, and you put it into an aqueous solution, like I said in the beginning, such as hydrochloric acid. How do you know it's a single replacement reaction? Well, if the reaction occurs, the metal you put in changes. Usually it will disappear, and something else will come out. In this case, we can see it coming out of the top right there, which is a vapor, basically, and it's not water vapor. It's a gas that can be lit, but now we don't have enough of it right there, okay? So that's what we're looking at right there. And so how do we know it's a single replacement? The way I just said was because the metal disappeared and something else came out. What came out was hydrogen gas. So the next question is, technically, chemical reactions you can reverse them, but in real life, chemical reactions are really hard to reverse. Could we put this back together? Well, not very easily, because we had a whole bunch of hydrogen gas that left, and we also burned it on its way out, so there's no way we're going to put this back together. Now for the equation, if you look it up, and I actually used it for an example in the notes, so if you go look at the notes, you should be able to find the balanced equation for this reaction. So this took a little bit longer than I thought, but it's almost the length of the lab. We're looking at about 8 minutes right here. You can fast forward through it, but that's what the aluminum and hydrochloric acid lab looked like today when the students did it in class. All right, Mr. E, signing off.